Moving on to one more classification, which the engineers in the recent past are employing this particular concept, that electromechanical relays are considered to be the first generation relays, as mentioned here. The second generation is the static relays, which do employ diodes, transistors, and ICs. These first generation, they use it to employ electromagnets, moving parts, as you might have studied in your machines, like armature, fields, poles, magnetic poles, etc. So they use it to employ these things. And next came the second generation. I think these two are covered in your PSP. And this is third generation relays, which do employ basic microprocessors. You might have studied this in your MPMC, how to program a microprocessor. And fourth generation relays or numerical relays, which do use advanced microprocessors, or what we call them as PC based relays. And nowadays, the recent past, you might be seeing this IEDs, intelligent electronic devices. This is the latest evolution in the relaying techniques. Maybe in the near future, you will be having completely IEDs replacing all these conventional relays. So, as far as our course is concerned, we will consider these things as digital relays itself. Anything which do use these processes, we will consider them as digital relays because they do employ digital techniques. So what is the difference between this first generation relays and the second generation relays and the next generation relays? That's the major difference between these things is these, as already told, a relay is basically a device which senses any abnormality, right? So how does it know that it is an abnormality? So which means that you are sensing a quantity and then you are comparing it with some preset value, isn't it? Which you call it as a, I think you might have heard about this pickup value, right? So these terms do appear whenever you are comparing. So I do have a preset value and I'm continuously monitoring the system. So I'm measuring the quantity, and if I feel that if it is beyond my preset value, whether it is higher or lower based upon my requirements, so I will automatically mention it as an abnormality in the power system, isn't it? So olden days, the first generation relays, they used to have this moving parts for comparison. Second generation, they used amplitude and phase comparators. The third generation relays, what is the improvement is that all the analog signals, whether it is a voltage or current, these are converted into digital signals, transmitted over a distance, and then they are compared, and then the output is again converted into analog. So since they do employ or they do convert this analog to digital signals, they do employ A to D converters and D to A converters. So since the signals are converted into digital, they are called as digital relays. So comparison is basically done in terms of digital information. So this helps in, the advantage of this is that, let us suppose if I do have a power system somewhere and I am at my home and I want to sense abnormality, I cannot have an electromechanical relay there and I can't go there. So immediately what I will do, I will measure the things there from the power system, which is somewhere around 80 kilometers away from me. So I'll measure the quantity. I will use a A to D converter there. So it will convert into digital data, transmits me. So nowadays transmission is available everywhere, right? We do have 4G communication, 5G communication. Transmission of data is very easy nowadays. So transmit the data from there. You get it at your home, you process it, and if you feel that it is beyond your limits, then you will give a signal, then it will automatically take it back from there and give it to the signal to circuit breaker. So this concept of having the flexibility of sitting at your home, sensing the abnormality, So this is one type of advantage which we are getting. Maybe let us suppose if you don't want it manual checking, then automatically you can have automatic checking also. The advantage is that you can transmit the data to some remote location. There you can have your entire processing things, etc., etc., etc. It will automatically process the thing, senses abnormality, sends it back to the circuit breaker, which then opens the circuits. So this advantage which you do have, that you can keep your comparing devices, comparators remotely from your workplace. So that advantage is given by a digital device. So in the future, you might be having this completely digital list. Even though it has its own glitches, but still, since there are so much research is going on in this area, the future is completely of the digital list. So every analog signal is converted to digital, transmitted over a distance, sensed, sent it back. Don't worry about the delays in the transmission. With the 5G communication, maybe in the future you may get 6G, 7G, 8G. The data will be communicated very, very fastly. So no need to worry about the time delays, etc. The only thing which worries in this digital world is that how safely you can protect your data. So if you do have proper protection things, what we call it as security, data security, then automatically you can work upon this digital list. The future is completely gone with this intelligent electronic devices also. So the detailed description about the advantages of all these relays, that we will discuss in our next slides, in our next classes. But as of now, I think you might have understood the development of these relays. Moving ahead now. Yeah, this is one more slide which I wanted to project here. This is 1900s electromechanical relays. They used it to be very basic relays, single function relays. And next came this 1964 static electronic relays. They used analog circuits, solid state devices, but they were multifunction. And in 1980s, microprocessors came into picture. This is, we call that microprocessor based relays. They used to have digital multifunctions. They were able to self-check themselves. And in 2000 somewhere, we had this microprocessor relays generation number 2. We call them as numerical relays. Very powerful multifunction devices. So this for the SCADA, now you might be knowing about this SCADA, etc., etc., right? So all this is smart grids SCADA. We do need the information very fastly. We do need devices which can have multiple functions. So with the invention of this microprocessor based relays, our SCADA has becoming more and more efficient. This picture has been taken from the internet. I have given the references in the last section also. Okay. Now moving ahead. Yeah. Now this is one more thing. As you can see, 1900s somewhere the electromechanical relays were there. See the evolution. 1901 the overcurrent relays, 1908 differential relays, 1910 directional relays, 1923 distance relays, and next is PLC, 1927 power line carriers. These were all conventional protections. And in 1970s, when we had these computers started coming into the picture, we had this rectifier, transistor, integrated circuits. These were all solid state devices. So static relays. We had this traveling wave techniques invented in 1970s and implemented in relays. Adaptive relaying, and now AI based relays are also coming to picture. Self-thinking capabilities there. So these are all modern protection things. And in 1990, see, SCADA has come into picture. This GPS has come into picture. So nowadays, this is the latest developments. Transient based relays, wide area protection, integrated protection, and every data is being stored now in the cloud, big data. So integrated protection is now coming into picture. So these are the latest trends which are happening in the power system protection. Now, let's have a quick look about, apart from your pictures which you might have seen so far, let's have a quick look. Relays were first developed in 1800s, but they gained importance in 1900s. They are generally used for electric protection, right? So the first foremost relays were electromechanical relays. Nowadays, we are they are being outnumbered by the microprocessor based relays, advanced microprocessor relays. But still, they are considered to be very standard relays, and which they use it to have very high perfection. The only problem with that was they were single function relays, and the sound was used to be very, very high because they use it to have moving parts. Their maintenance was very high. So that's why they are being outnumbered nowadays. So the very first electromechanical relays, they were used in circuits of long distance telegraphic. So long distance telegrams, they use it to have this for amplifying the things. So next, they were commonly used in computers and also in telephone exchanges basically to sense any abnormalities. Particularly, they were used for performing logical computations and operations. But later on, in 1960s, static relays came into the picture. They started pushing this electromechanical relays to the brink. So static relays became the normalcy in 1980s. So, and next later on, digital relays started coming to picture. Digital relays now are very accurate and reliable. And since they use microprocessors, nowadays advanced microprocessors, they can have multiple countings. So they can be used for multifunctions also. A small memory chip if it can be installed with a microprocessor, then it can do multiple functions, right? It is just like your PC. In your PC, you can play games, play songs, you can do whatnot, everything, right? So a PC can do multiple functions. Similarly, if you can employ a PC, it can do multiple functions. In olden days, an electromechanical used to do only one function, whether to sense current or to sense voltage or to sense frequency. Only one function used to be there. But nowadays, multiple functions are being happening now. So, as already mentioned, they are the future. Okay. So, coming to digital relays, they entered the market in somewhere in 1980s. Nowadays, the feeder protection, the distribution protection, etc., completely is now taking place with the digital relays itself. They do employ microprocessors, and if the applications are small, they will employ microcontrollers. You know the difference between a microprocessor and a microcontroller, right? So, what is the biggest change when compared to the previous generation relays is that here all measured analog quantities are converted into digital signals. This is what I have mentioned here. If you carefully see, yeah, all measured analog quantities are converted into digital signals. So for this one, they will employ A to D converters, analog to digital converters. You might have seen this one in your ADE subject. And this digitalized data is then utilized by the microprocessor for processing. So you will be having a protection algorithm which checks the digitalized data. So what type of thing you will be using, what type of algorithms? You might have come across as Fourier transforms, right? Fourier transforms, Walsh functions. So all these are used on this data to sense the faults. So the protection algorithms may be based on discrete Fourier transforms. You might have studied in your SLS, right? So this is a representation of a digital relay. Shown on the screen are two separate relays of digital phenomenon. And the advantages of using digital relays, mentioning again, they do have high level functionality integration. They can be used for multifunctions, and they can monitor any additional works also. And they do offer us very high flexibility. And the biggest thing is that they can work under a wide range of temperatures, unlike the static relays. So that is the advantage of digital relays. And also, they can implement any complex function. All we need is nothing but a good engineer who can develop a particular flexible algorithm. And they do have this self-resilient thing. They can self-check and also they can adapt to any environment. And the biggest thing is that they can communicate among themselves. And nowadays they are very less sensitive to temperatures, and also there is no question of any aging. See, it's only about technology changes. There is no question of any physical aging. And nowadays, with the advent of so many technologies and so many researches going on, now they have become economical. So, to conclude this thing, I can say that the future is all about digital relays, and they do employ microprocessors, and they do have this A to D converters. So all the data is being converted into digital data and then process it by some processes to sense any faults, any abnormalities in the power system. So that's it from my side. These are the lecture level questions. So I'll be asking one more question. So this is the introduction, so I'll be asking only one more questions. So state the need for protection in the power systems and what is significance of digital protection. Okay, so these are the references. You can go through these references, and thank you. We will again meet you in the class.